morning, Daniel. Why students are not joining? It's 2 minutes.
Sir, I put a message now.
Should I give the message in WhatsApp?
Yes, sir.
मेरी डायरी तो नहीं छोड़ा ना।
Next. Good morning, one and all.
Good morning, sir.
Okay.
Good morning,
sir.
Good morning. See, today you sit with the calculator and your notebook. We will solve some numericals on work energy principle. So you can arrange it in that minute. Till then, I will share the screen.
तो इसके ऊपर लिखना है क्या है, डिजाइनिंग है, मैन्युफैक्चरिंग है, क्या है वो सब लिखना है।
Just a second, guys. So, are you ready?
Yes, sir.
Okay. So, just for revision, I will tell you what we covered last lecture. So, we have seen these two principles which are used to solve the kinetics problem. One is D'Alembert's principle, and the second one is work energy principle. Okay. So we will make use of work energy principle to solve the problems. Okay, and we will see the two problems which are generally repeated. Okay, in the paper of KOM. If you want more information, like if you want to do more practice, you can always refer a book for it. There are many problems given. Okay, so it is your problem, you can note it down. Then I will explain what is actually the problem is and how it can be solved with the help of work energy principle. You can read it in a minute.
Yes, sir.
Okay. To see all of you. Okay. So try to understand this statement. Okay. What is given in there, that there is a sphere of radius zero point 0.2 meter and it starts rolling without slip up an inclined plane. Okay. So I will draw. There is an inclined plane like this, and say it is your horizontal reference. Okay. Now what is given, that the angle of inclination of the inclined plane is 30 degree. So this angle you can call it theta. Theta is equal to 30 degree. If the now sphere is starting rolling over it, means you can assume one sphere here like this, and it is rolling over the inclined surface. What direction is given of the rolling? That it is rolling in up direction. It is rolling in up direction, and it sleeping is not happening. It is just rolling like this. Okay. If the initial angular velocity of the sphere is 10 radian per second, okay, means the velocity with which it is rotating is your omega 1, okay, which is given as 10 radian per second. Determine how far the sphere will travel before it reverses its motion. Okay, what will happen? Say at initial position, it has some angular velocity, so it has kinetic energy. With the help of this energy, it is going up the inclined plane. Okay, but what will happen after some time? It will uh, lose up all of its kinetic energy, and it will halt there. And after that, because of gravity, it will reverse its motion down the plane. Okay, so now you have to decide that how much distance this sphere will move up an inclined plane. Okay, so suppose it is the initial position of the sphere. It is the initial position of the sphere, and after some time it will come to this position. Okay, at this position, particular position, what is given, that it changes its direction, it reverses its direction. So say it is the position 2. In position 2, say angular velocity is omega 2, and as it has halted its forward journey, so at position 2 you can say that angular velocity is 0. Angular velocity is 0. Okay, here what is angular velocity? That is 10 radian per second, which is given. Okay, so you can say that when the sphere will move from position 1 to position 2, the change in kinetic energy. Okay, change in kinetic energy. How you will calculate the change in kinetic energy? Delta E, or delta of kinetic energy, Ke, is nothing but what is kinetic energy, final kinetic energy 2 minus kinetic energy 1. So as angular velocity is 0 at position 2, okay, kinetic energy will be 0 at position 2. So final kinetic energy is 0 minus the initial kinetic energy. So how to calculate the initial kinetic energy? What is the formula for calculating the initial kinetic energy?
Half mu square.
1 half mv square, but that is in case of the your linear motion, right? 1 half mv square. Now we are dealing with the angular motion, so formula will be your 1 half I omega square, 1 half I omega square. Okay, so I will write that here. Delta E will be 1 half into I omega square. Okay, it is the mass moment of inertia I into omega square. Okay, as it is the initial angular velocity, I will use the omega 1, 1 half I into omega 1 square. In this way, you can calculate the change in kinetic energy. Okay, and this change in kinetic energy we have to equate with what is work done during the movement of the sphere from position 1 to position 2. Okay, so what is the formula for work done? What is the formula for work done? You write WD. Okay, work done you can write with the help of this equation, as it has moved linearly. Say the distance between these 2 points, initial position and final position, is s, or you can denote it by x, whatever. Okay, so work done can be given by force. What force is acting? What force is acting in the direction of displacement s? It is the formula for work done. As this roller has undergone the translatory motion, we are using F into S to calculate the work done. Now what force is acting in this particular direction? See, the direction of distance or displacement is this, along the plane. Along the plane displacement is happening. Okay, so as there is no force acting on this, the force acting will be the internal force of the sphere, and that internal force is nothing but its weight, right? Weight of the sphere. Okay, and what is the direction of weight of any object? वेट किस डायरेक्शन में एक्ट होता है?
Downwards.
Downward.
Vertically downward, right? Vertically downward. So say here is the CG. I will draw a line vertically downward, okay, and I will show the force. Force is equal to mg, that is the weight of the sphere, okay. But in order to calculate the work done, you need a force which is acting in the direction of displacement, okay. And this particular force, that is weight of the sphere, is acting vertically downward, okay. So now I have to find a component of this weight which is acting in this particular direction, that is along the plane, okay. So I can say that I will resolve the weight along the plane and perpendicular to the plane in two components, okay. How we can we can resolve it in two components? For that we need some angle.
Mg cos 30 and Mg sin 30.
Mg sin 30 will act along the plane or perpendicular to the plane?
Along.
Mg sin 30 will act along the plane, correct. So if you see the geometry, okay, this angle 30 will be reflected here. This angle will also be 30. Say this angle is theta, okay. Now you know that the component which is along the angle is cos theta, mg cos theta, and the one which is opposite to this angle is mg sin theta. So mg sin theta will be acting in this direction, okay. This component mg, say mg sin of 30, mg sin theta, okay. So mg cos theta, you know, this force is acting in this direction, okay. But there is no displacement in this particular direction which is perpendicular to the plane. The displacement is along the plane, so I will consider the force which is acting along the plane, okay. So how I will find the work done? Work done will be equal to, what is the force? Force is mg sin theta, so I am adding minus sign because the displacement and force are in opposite direction. Displacement and force applied is in opposite direction, so my force will be minus mg into sin theta. Value of theta is 30 degree, multiplied by distance which we have to find, okay. S we have to find, okay. Now work energy principle says that whatever there is change in kinetic energy, it is converted into work done. Some work is done at the expense of kinetic energy, okay. So I will equate these two. Delta E is equal to work done. I will equate this and this. Now you tell me what you need to find out the answer. What is unknown? See, omega 1 is given 10 radian per second, okay. Then you need mass of the uh, sphere, right, okay. And I, that is your mass moment of inertia, okay. So as I told you that mass formula of mass moment of inertia is given as standard. It is derived, and for sphere For sphere, it is equal to 2 upon 5. Okay, 2 upon 5 into क्या फार्मूला होता है मास मोमेंट ऑफ इनर्शिया का m के स्क्वायर राइट 2 upon 5 m into r square. Okay, so if you compare it with mk square, then you can find out what is k. Okay, k will come like r into root of 2 upon 5. Okay, so this particular mass moment of inertia is about the centroidal axis, the axis which is passing through the centroid. For example, here, okay, the axis which is passing through this point, through the center, around that, this is the mass moment of inertia. But this particular sphere is rolling about this point. See, when it is rolling like this, it is turning at the point of contact. Okay, it is not turning about this particular center. Are you getting the concept? Okay, say this is the IC. IC means the mass moment of inertia about the axis which is passing through the centroid. Okay, but what we want the mass moment of inertia about the turning point here, the axis which is passing through the point of contact. So for that we use the parallel axis theorem to calculate the mass moment of inertia. Okay, so how you will calculate, say, mass moment of inertia about the point ICR? You call it an ICR point because about this point of contact, this sphere is turning. About ICR will be equal to what is about the centroid, that is IC, mass moment of inertia about the centroid, plus what is mass of the sphere multiplied by the distance h, का square. Okay, it is the formula which comes from the parallel axis theorem. Okay, now I will explain you what is that. For example, say it is an object, right? And it is its axis of rotation. About this particular axis of rotation, say the mass moment of inertia is 1, I1. This is the axis 1. Okay. Now suppose you want to find out mass moment of inertia about any other axis 2, and the distance between these two axes, the distance between two axes is h. Okay, and say the mass of this particular object is m. Then if you know the mass moment of inertia about one axis, you can find the mass moment of inertia about any other parallel axis. So axis 1 and axis 2 are parallel. We can use the parallel axis theorem for that. So according to parallel axis theorem, your I2 will be, what is I1, that is moment of inertia about axis 1 plus what is the mass of the object, right? Mass of the object, and multiplied by the square of the distance between these two axes. Okay, so in this way you can find the mass moment of inertia about the parallel axis theorem. So same concept we have applied. We know the mass moment of inertia about the centroid, but we want the mass moment of inertia about the point of contact, because the sphere is not turning at around the axis, around the centroidal axis, it is turning around the point of contact. So with the help of parallel theorem, we applied the parallel theorem IC plus m into h is square. Now h is what? H is the distance between these two axes. So one axis is passing through the center of sphere, and one axis is passing through the point of contact here. So what is the distance between these two? The distance between these two is
The radius.
the radius. Okay. So here in this formula, h will be equal to radius of the sphere. Okay. So radius is given. Now you can add these two, IC plus mr square. You add these two, you will find out the area moment of inertia about the ICR point of contact, and this value you will put in this formula to calculate the initial
Sir, mass moment of inertia. Na?
kinetic energy. Yes. uh,
Sir, you said area moment of inertia.
Mass moment of inertia, sorry, mass moment of inertia. Actually that I'm also teaching that MD1 subject, that's why, and that is frequently coming in there. It is mass moment of inertia. Got it?
Yes, sir, yes.
Yes. Okay. So I think I have shown you everything. Right now I will expect the answer from you. Okay, you solve it and tell me what is the answer. See, it is very simple. You have to remember this. Work done, work done is equal to change in kinetic energy. Okay, you have to equate these two. Delta E is equal to work done. So ये माइनस और ये माइनस कैंसिल हो जाएगा यहाँ पर, ठीक है. देन मास इसमें भी है, मास गिवन नहीं, मास इसमें भी है और मास मोमेंट ऑफ इनर्शिया में भी है, मास मोमेंट ऑफ इनर्शिया. So this mass will also get cancelled. Okay, and remaining parameters are given like g, you know, 9.81 meter per second square, theta is 30, then your radius is 0.2 meter, it is given here 0.2 meter, and angular velocity, initial angular velocity is 10 radian per second. Then you will be solving it and telling me the answer. Yes, please type your attendance in chat box.
5.6 meters.
5.6 meter or 0.56 meter. We check. So sine 30 is 1/2. This 1/2 will get cancelled here. Here it is 9.81 and this is 0.2. So how it will be solved? 0.2 square. 0.2 square is 0.04 multiplied by 100. 0.04 into 100. 4. Okay. Are I answer?
Yes sir, I had taken gravity as 10. इसके लिए वो थोड़ा error था.
देखो 0.57 मीटर आ रहा है आंसर.
Yes sir.
Yes. Others please verify. Then we will start the next question. Guys, how many of you got the answer?
Yes, sir.
Okay. And like what happens, you don't even need to solve more problems on kinetic energy. Means you can save your energy because this numerical along with the next one are repeatedly asked. Okay, and anyway, if you are lucky, they may be asked this time also. But like you are quite interested in mechanics and all, then you can go for more numericals also. Okay. Okay, next we will see again the same problem. Not same. First you try to imagine the situation and make a drawing of that how it is. Okay, and then think how you can solve it with the help of your work energy principle. Okay, first you read the problem and note down. So in a day or two, or like on Monday, I will be preparing a simple prerequisite test, okay, for KOM. It will be simple, like you can use the knowledge of your aptitude, numerical solving, okay. So I will ask you to appear for that also, and don't share the questions of the your prerequisite test for KOM, because I'm not going to count it anywhere, not in Tumblr, not anywhere. It is just for like what you need to understand this subject, okay. And to appear for that prerequisite test is will be compulsory. So maybe I will keep the quiz open for one day, and as per your convenience, you can attempt it. But remember, do not take any help. Do not open the book. Like, okay, it will not be counted anywhere. And you have to join back immediately. So as you can imagine, okay, come to this example that there is a uniform bar, means rod of mass m and length l. It hangs from a frictionless hinge. Hinge means that pivot point से वो hinge कर रहा है, pivot point से hang कर रहा है, okay. It is released from the horizontal position, okay. So it is like this. Bar is there, a rod is there. It has mass m, and length given to us is L. So as what will happen, as the bar is uniform, you can assume that it is uniform in cross section, okay. Same cross section is there. Its center of gravity, that is G point, CG point will be at L by 2 distance, from the point it is hanging from. Say it is the point it is hanging, like this, okay. See, it is not fixed here, it is a pivot point, pin joint, okay. Now what you did, you released it from this position, like uh, you hold it in hand in the horizontal position and then release it from here. So it will swing around this pivot point. Say this pivot point is point O, okay. It will swing like this. So when it will reach in vertical position, it is its horizontal position